Welcome everyone to this DSA training workshop. Before we start the session, we have with us Professor Shyamalendra sir. He's gonna speak a few words and then we can move on. So sir, you can take over.
Okay, thank you Neeraj, and thank you to whole CodeIIEST team. That first of all, I want to express very good evening to all of the students. I think all of you are from different core branches. Actually, this initiative actually started with the request from one of our beloved professor, that is Bhaskaran Bormon from Electrical Engineering Department. One day, actually, he requested me that to start some type of session regarding, that means, on the topics of data structure, algorithm, that is the database, or the object-oriented programming with that. Then I told that, sir, actually that not all these topics can be covered, but that means from our code, that is from our CodeIIEST, we can start some session on data structure and algorithm. Actually, he requested mainly because of that the syllabus of mainly the core branches. Actually, I'm not saying about the IT branches, that is IT, CST, or the ETC branches, except those core branches like the electrical engineering, civil engineering, that is mechanical, aerospace, that is the mining engineering. So all of these, they have their core subject, but they actually get the flavor of coding only in the second semester when they have that is basic of computer programming. After that, I think in their syllabus there is no touch of other type of coding thing. But most of the recruiter, those actually come in the institute, those are the mass recruiter, and those are from different software industry. So mainly the student from the core branches, they actually feel some problems while facing these types of interview, because mainly there are the question from that is that algorithm, data structure, those are being asked. And that means that if we just keep aside this type of canvassing or all these things, till in your life also, that means when you are learning, then nowadays the technology has been advanced so far, that means there is no such boundary exists between that this one is computer science, this one is IT, this one is non-IT, this one is core branches. This type of boundary are actually erasing as the technology is being progressed. So those students who are from electrical engineering, you will also find that you also have to work with some type of microprocessor based system like the Arduino, GP, this type of things. And there are actually what those are the main thing of the processor, those are a type of a microprocessor, and for that you need some type of coding knowledge. It means when you want to do something, or when you want to implement something new that may run like a motor, or maybe some type of step-up motor, or maybe other type of thing, then also you need the knowledge of a type of basic of some type of coding thing. So then I actually contacted Arnav and I asked him that means to discuss with your team whether we'll be able to start this type of session where we can discuss about some type of data structure, some flavor of algorithm, this type of thing or not. Then I'm that thankful to Arnav and his full that CodeIIEST team, that within I think 2 hours they are ready with all of these, and within evening of that day they prepared the brochure, and I sent this brochure to the dean student for getting his permission, and that means I also discussed with him by phone. Then he actually keep the permission. Then they actually construct the syllabus which will be discussed, etc. So then we have planned to start this course from today. So here in this total, that means this course, you will get the flavor of data structure. Data structure is very important. Data structure everywhere, because stack, queue, sorting, searching, this type of thing are that you need everywhere. Then after that, you will get the flavor of algorithm. This algorithm is very important because that means which type of programming you will use. That means whether that means when we are writing some type of programming which will take less space, which will take less time. That means you will be able to get a basic knowledge about the time complexity, space complexity, etc. And we always favor that type of algorithm, or that is that based on that the particular programming that will be written, which actually take less, which actually has less time, that is less time complexity. So I think you will all enjoy this total syllabus, total course, and from this course, I think you will be able to gain something. So again, I want to express my heartfelt thanks to So, does anyone have any type of that query before starting of this of the classes of the course? Any student have any type of query? I'm seeing here about that 70 students, more than 70 students. The space was limited, so for this reason we have to make it within. That is, I think that was 95. Is that? Niraj?
Yes, sir.
95. Yes. Okay, 95. Because we are not able, because this means we have to do all these classes by using this Google Meet. So 95 we have kept this one. Okay. After successful organization, if we find, then we may think of some type of other courses. We may think, but at the beginning we want to start this one. And just first of thing, that means the teacher, they are not us, those are all your seniors, so you can freely that means ask them any question or any doubt, and I think they will be able to make those clear. I think this class will be some type of enjoyable class. You will enjoy this one, and you will also learn this, you will also get something. And after this, that means this organization, that they told that within that 10 minutes this total seats were filled up. Then after that I also received some mails, but I have to tell them sorry, because we do not have that amount of seat. So those students who are actually getting some knowledge from there, you also try to that we discuss this one with your friends. If they ask you, that means what have you gained from there, at least you try to. And I also, that means ask Niraj to make this one recorded. So if some student who are not able to join, we can share this type of recording with them also. So do you have that type of recording? Do you have the type of recording facility with this? That means
yes,
this Google Meet. Okay, so I think you can easily record this one. We can place this one in the YouTube also. Okay, Niraj. Thank you, student. And if you have any query, you can ask. If you have any query regarding this course or anything, you can ask. Any query by any student? I think no. So Niraj, again, I want to express my thanks to all of the teams of CodeIIEST. So you may start.
Okay, sir. Thank you, sir.
Okay.
So let me share my slide. I suppose it is visible, right? If anyone can write in the chat box.
Yes, it's visible.
Okay. So before I start the session, I would like to say a few things that if in case you have any doubt, please write it in the chat box. I will take your questions from time to time. I will check the chat box. And this session will be divided into two parts. First will be the theory part and the practical part. The theory part will be taken by me, and the practical part will be taken by Fahim. So we both are from computer science department of second year, and this first session will be on basics of programming. So these slides will also be shared after the session in the WhatsApp group. So let's start with what are our the objectives. The first is the introduction. We'll learn what is programming, then why so many languages are there, then we'll learn about C and C++. Then we'll go with to learn about compiler versus interpreter, and then we'll know about GCC. Then I'll start with the main C++ language. C++ is the language that we have chosen, and we will discuss everything in C++ throughout this entire workshop. So it will start from here, tokens. Tokens are of 6 types: keywords, constants, identifiers, special symbols, strings, operators. Then we'll move on with literals, data types, then header file, cout, scene, then conditional statements and loops. So everything will be basic here. If in your first year also you have count across all this. So let's start with what is computer programming. So computer programming is a process of composing and organizing a collection of instructions. So these are instructions that we give to a computer to perform certain tasks that we want. So there are many types of programming languages like C++, Java, JavaScript, Python, Ruby. So using appropriate languages, we can make softwares for different purposes, like a program that helps scientists with complex calculation, a database that stores huge amounts of data, a website that allows people to download music, an animation software that will allow people to create animated movies. So these all are the softwares that we can create with different programming languages. So now this question might have arisen in everyone. So why are there so many programming languages? You have heard about C, C++, Java, JavaScript, Python. So why are there so many? So the main reason why there are so many programming languages is because different problems require different set of tools to solve them. So each programming languages has certain feature and characteristics that make it suitable for specific tasks. So just like how doctors have different specializations like dentist, neurosurgeon. So a dentist can't go to a neurosurgeon's operating table and do operation there. So they have their own specialization and own set of tools to solve their problems. So before moving on to C++, we have to talk about C, because C++ is just an extension to C. So C programming is a procedural programming language, and it was initially developed by Dennis Ritchie. So this is a picture of him. It was developed in 1972 as a system programming language to write operating systems. So it was developed to write operating systems only. The main features of C include low-level access to memory, simple set of keywords, and clean style. And then we'll move on to C++. So C++ is an object-oriented programming language. It was developed by Bjarne. It's pronounced as Bjarne Stroustrup. It was developed in 1979. So this is a picture of him. So it is an extension to C language. It is a middle-level language, rendering in the advantage of both programming at low level, that is drivers and kernel applications, and even higher level applications like games, GUI, desktop apps. Both C and C++ are middle level language. So C++ gives programmers a high level control over system resources and memory. So now we'll talk about compiler. Compiler is a software. Compiler is a software that translates or compiles source code written in high-level language into a set of machine instructions that can be understood by a digital computer. So this is a picture. This is a source code, and this compiler converts it into a machine code. Machine code is a binary file a bunch of zeros and ones. So that is what the computer understands. Computer doesn't understand C++, Java, JavaScript, all that. It only understands the binary language. So there's also something called as interpreter. You might have heard of Python. It is an interpreted language. C and C++ is a compiled language. So this slight difference in machine code. Machine code is here and machine code isn't here. So what compiler does is it scans the entire code and converts it into a machine code. That is a bunch of zeros and ones. It will create a separate file, that is .exe file. You might have played games with the .exe extension. So that is also a binary file. So it will scan your whole C code into a separate, it will create a separate file called as .exe, and in Linux it is .out. So, but interpreter does not does that. It does not create a separate file. It will scan your code line by line, and it will just perform the operation that you have given, the instruction that you've given. It will create the instruction and it will send to the computer and give you the instructions. So if in case you have any doubt, I'm taking any doubt before I move any forward. So if you have any doubt, please write it here. I will take pause from time to time to address any doubts. Okay, I'm moving forward. So this is an image where your .c code is converted into a binary file. So bunch of zeros and one. Compiler does this. So now we'll talk about GCC. So GCC stands capital GCC. So GCC stands for GNU Compiler Collection. It is a collection of compilers that includes front ends. Front ends means it includes compiler for C, C++, Objective-C, Fortran, ARA, Go, D. So these all are languages, and the GNU, it is a collection of compilers. It will have compiler for each of them, as well as libraries. So GCC, it was originally written as a compiler for GNU operating system. It is a type of operating system. Before it was for Linux. You can say Linux operating system are also the GNU operating system because there are some softwares. So I will not go into that. So it was first released in 1987 by Richard Stallman. This is a picture of him. The GCC 1.0, it was released in 1987, and it had only compiler for C. So later on, many other compilers came into it. So let's move on to the next slide now. It only handles C program, tokens. So now we'll start the C++ language. So while learning C++, the first thing that we have to learn is tokens. Tokens is the smallest element of a program that is meaningful to the compiler. So tokens are classified into 6 types: keywords, constants, identifiers, special symbols, strings, operators. So we'll discuss each of them one by one. Strings will be went into details in future sessions. So I won't tell much about it here, but you will get to know about it in future session. So there are 6 types of tokens that you have already seen. So these are some examples. So keywords example are int, while, float. Identifiers, you can say it is a variable, some total. Then constants are any like 10, 20. Then strings in double inverted commas, ram, hello. Special symbols are braces. Operators are plus, divide, minus, multiply. So now let's start with keywords. Keywords are predefined or reserved words. It is already defined in the compiler. You can't change it. So every programming language has their own keywords. So each keyword is meant to perform a specific function in a program. they can't be used as variable names. So these are different types of keywords that are there. I will discuss about a few of them. But if you have any interest, then you can also check this slide and learn about it yourself. There are many more keywords. Now we'll talk about constants. Constants refer to fixed value that a program may not alter. They are called literals. Like 10, 20, these are constants. Constants, wait a sec. Literals are 10, 20, like 1, 2.5c. And constants are the variable that we allocate with literals. You will see in the future, next few slides, I will discuss the difference between constant and literals. Constants can be of any of the basic data type. It can be of integer, float, character, strings, Boolean values. So literals are data used for representing fixed value. They can be used directly in the code. So these represent fixed value, and this represent a container that holds that fixed value. Okay. There is a slight difference. So this is an image, how you declare constant. You cannot declare constant like constant in var and not give any literal value to it. You can't just declare it const in var and then declare a...
Can you record the session?
It is being recorded by someone else.
Okay.
I'm not recording, yeah. Okay, yeah, it is being recorded, don't worry. Procedural programming language. So I won't go into the depth of it because I have to complete the session on these topics. So you can say it is a style of programming language. You have heard about OOPS, object-oriented programming language. Like that also, it is a procedural programming language, is a style of programming language where we don't use classes. We don't contain everything into a object class, something like that. We use only functions and all, function structures. So yeah, I was here. So this is the correct way of declaring and initializing a constant. So const keyword, it is a keyword. Then int, it is a data type, and var, it is a variable identifier, and will associate it with a literal. This is a literal, 5 is a literal. This var has become a constant. So var is a constant. This is the difference between literal and constant. So const data type, you have to give the data type, otherwise it won't, the compiler will give error. So this is how to declare it. So now we'll move on with identifier. So identifier are used as the general terminology for naming variables, functions, and arrays. So these are user-defined names. You can give any names, but there are some rules that you have to follow while giving them names. Like it has to start with either letter or underscore. It can't start with a digit. So these are user-defined names consisting of arbitrary long sequence of letters, digits, with either a letter or underscore as a first character. This is important. Otherwise, your compiler will give an error. So identifier names must differ in spelling and case from any keyword. So it is case sensitive. Capital, all capital, like my name Neeraj, and all small Neeraj, those are different identifiers. So these are some rules. I won't go into the details of it, but just to the important parts are that these special characters are not allowed. Then starting should be either a letter or digit, letter or underscore, not digit, and case sensitive. These are some important rules. Rest you can read it. So special symbols. Now we'll move on to special symbol number 4. This is the number 4 keyword. We have completed 3 keywords till now. This is number 4 keyword. Number 4 token. First was keywords, second was constant, third was identifier, and this is the 4th token, special symbols. So apart from letters and digits, there are some special characters in C++ which help to manipulate and perform data operations. So each symbol has a specific meaning to the C++ compiler. So this is a table of all some of the special characters. So square brackets, symbol brackets, curly brackets, comma, hash, compound, preprocessor, asterisk. So I won't go into the details of this. You can read it from here, or also research upon it yourself. So I have given this for your reference. Now we'll go into the fifth token, that is strings. So string has its own definition. In its own definition, is a way to represent a sequence of character as an object of class. And this class is called std string. String class stores the character as a sequence of bytes with the function of allowing access to single byte character. So I'm only giving the definition here. In another session, it will they will talk about it in details. So this is an example how you initialize a string. So string xtr in double inverted comma hello world. String is a keyword, and this is a literal string literal, and this is the identifier. So now before this was our fifth token. So sixth token is operator. So before moving on to operator, I will be discussing data types. So all variable use data types during declaration. You have seen in here data type. This string is a data type. Then there was int, constant, int is a data type. So we have to for a variable declaration, we need to declare it with a data type. So it is important. Otherwise, the compiler won't understand what kind of variable it is. So because it needs to reserve that amount of memory, I won't go into there, but just some few words about memory. So all variables use data type during declaration to restrict the type of data to be stored. So when a variable is defined in C++, the compiler allocates some memory for that variable based on the data type which it is declared. So data type declaration, we have to give the data type. It is important. Every data type requires different amount of memory. That's why. So these are the different data types. This is primary data type, integer, character, boolean, float point, double float point, void, white character. These are derived data type. Function, array, pointer, reference. And these are user-defined data type, class, structure, union, enum, typedef. So in this session, I'm going to tell only about the primary data type and only function, which is a part of derived data type. So array will be covered in a different session, and pointer and reference won't be covered in this workshop. So primary, it is also called primitive predefined. Primary data type is also called primitive and predefined data type. So these data types are built in. It is already defined in the compiler and can be directly used by the user to declare variables. So example, int, char, float, bool, etc. These are primitive data type. So int, character, boolean, float, double floating point, void, white character. So we'll discuss each one of them one by one. So keyword used for integer is int. Int is a keyword that we use to refer it. And we've talked about memory space, right, in this slide. So integer requires 4 bytes of memory space. And the value that it can hold is from this one. It is actually 2 to the power 31. And this is 2 to the power 31 minus 1. That is how you can remember 31, 2 to the power 31, because this is difficult to remember. So now let's move on to the next data type, that is primitive data type, that is character. Character data type is used for storing characters, and keywords used for character data type is char. And character data type typically requires 1 byte of memory space, and it ranges from -128 to 127 or 0 to 255. So this is a bit confusing if you think. If you refer to this Ascii table, let me open it. So each character is associated with a value. That is, A is associated with 97. So that's why you find this 0 to 25, because say it is 0 from 0 till 255, sorry. So these are all the integers associated with the character. So you can use them interchangeably in a way. I won't go into that, but I've given the link of this Ascii table, so you don't need to remember all this. You can just important is all the letters A, B, C, D to Z, and capital A to Z, and numbers. These are frequently used in most problems that you get. So yeah, now let's move on to Boolean primary data type. Boolean data type is used for storing Boolean or logic values. This is 0 and 1. Boolean value can store either true or false. Keywords used for Boolean data type is bool. Bool is the keyword used. So floating point. Let me take questions before I move on. If you have any questions. No questions? Okay. So floating point data type is used for storing single precision point values or decimal values. It is used for storing decimal values, and it is keyword is float, and it requires 4 bytes of memory space. Now there is double floating point is used for storing a larger decimal value. And the keyword uses double, and it requires 8 bytes of memory space. Now, this is a primary data type called void. It means it does not hold any value, so it is a valueless entity. We needed something to represent nothing, so that's why we use void. It is very important for representation of nothing. It has various applications. That's why this came in C++ or C. So void data type is used for those functions which does not return any value. This is one application for returning a function which does not have any value, will return nothing. So it returns void. So the data type of that function is void. So now there's something called as white character. White character is a character which has larger. You have learned about character in this slide. So white character, in the word white means it holds a larger value. So white character is also a character data type, but represented by wcar_t. This is a keyword used to represent white character. So character required only 1 byte space, and white character requires 2 or 4 bytes. So it depends on the compiler, and car can only take 256 values. You have seen from this table, it can hold 0 to 256. That's why zero-based indexing. That's why it is 255, the last. So it can take car can take 256 values. Entries in this is Ascii table. On the other hand, white character can take 65,536 values. So which corresponds to Unicode values, which represent recent international standards, which allows for encoding for virtually all languages and commonly used symbols. Like example, it is used when international languages like Japanese are used. So white character, then we'll move on to the derived data type. So there are 4 derived data types: functions, array, pointers, and reference. So I will only talk about functions in this session. So functions is a block of code or program segment that is defined to perform a specific well-defined task. A function is generally defined to save user from writing same lines of code again. Did someone say something? Okay. Yeah, rather than writing same lines of code again and again, you can just use the function. You'll write it once and just use it again and again. So main is also a function. It is a default function that is defined in every C++ program. So whenever you write your code, you'll start writing from main. So, and when the compiler scans, also it scans from the flow of control starts from main. So now some important points about functions. So every C and C++ program has a function called main that is called by the operating system when a user runs the program. So every function has a return type. Functions should have a return type. It should return something. If a function does not have any value, it does not return any value, then it is void. So it returns nothing. Void is also a return type. So moreover, if the return type of the function is void, we can still use the return statement in the body of the function. Body of the function definition by not specifying any constant variable, etc. with it, by only mentioning return. So this is a void return type function. So if we give, if we don't give also return, it will still work. If we give return, it will still work. So when it will reach the end of the braces, then it will exit out of the function. But if you give return before in the starting itself, then from at that point only it will break from that function. It will come out from the function.
Acha, Neeraj.
Yes.
Yeah, will you have finished in 5 minutes? Like 5 minutes?
No, it will.
I'm just asking because I want to go to the washroom once.
You can go. You can go.
Okay.
Take
Sure.
So now we'll talk about the main function. It is the most important function, and it is in every C++ code that you write. Main function is there. It is a special function. Every C++ program contains a function called main. It serves as an entry point for the program. The computer will start running code from the beginning of the main function. So this is the syntax of the main function: int main braces start braces end, and there is a return 0, and you write your code according to different problems. You write your code here. So now we'll talk about header file. So we have still not went into the number 6th token. I've left it for the last because I want to cover all this in between and then give you a full code. So I cannot just give you the full code without talking about header file, main. So, and in operator, I will also discuss some questions. So I would recommend you to answer that time. So header file. Header file is a C++ language. So it is a C++ language. C++ language has a numerous libraries. There are some libraries you have. It is predefined. It is predefined in the compiler itself. The header files. You have. You can recall if in your first year you have used stdio. That is a header file. So you don't really know what it actually is. Besides knowing that it contains few words, few functions like printf, scanf. It is already defined there. So C++ has numerous libraries that include predefined functions to make programming easier. In C++ language, header files contain a set of predefined standard library functions. So your request to use a header file in a program by including with C preprocessing directive, #include. By including a header file, we use its contents in our program. So in C++, .h extension is not necessary, but in C, it was necessary to include the .h extension after each and every header file. So it offers the above features by importing them into the program with the help of preprocessor directive. So there's also, you can, go into details about preprocessor directive. So I won't go into that, but I'm just leaving the term here. I encourage you to check this out yourself to revisit concepts if in case you forgot it. So with preprocessor directive with hash include, we can give we can include the header file into our program. Then we can use scanf, printf, cout, scene, all those. So this is a C++ program structure. Hashtag include IOStream. This is a header file. That's how we include the header file. Then there's something you might have seen this using namespace std. It was not in C, but in C++ there it is there. So even if you don't use this, there's another way of writing your code. So it is basically tells the scope of IOStream header file. This is a complex topic. So for now, you can just say that inside the IOStream header file, there is a scope called std namespace. So it is used to access those access inside that scope. So either you use this or you just write std here. So I will go into that again. So first header file, then scope, then int main, then there's a body, then return statement. Then this is a most basic C++ program structure. So now we'll learn about the keyword cout. So we'll first include the header file, then write the namespace, then we'll write the main body int main function. Then we use std cout hello world. This is used to print in your computer. So if in case there's no doubt, right? What is the use of return statement? To send some data from a function here. So either you write this using namespace std or you write std here itself to use only for cout scene, all this, not for everything. For cout scene is defined in the header file. For this we need std. You can write this or this. Okay, anyway, now we'll move I will also tell about a few things outside of the topic. That is it is not recommended to write like this because it can create some collision. For our purpose, for general programming, it is not our concern, but for writing big softwares using C++, we use it like this. And for our convenience to not write std again and again, you can use this. It is completely fine. So we have seen how to print something. Now we'll see how to take something from our keyboard or user. So first, like we do always, header file IOStream. To use scene and cout, we need this header file IOStream. It defines what is scene and cout. If you don't write this, compiler won't understand what is scene and cout. So we declare a variable int a. We use scene and this arrow operator to take something from the user. So whatever you write in whatever values you give in your keyword, it will store it in this variable a. Then when you cout it, that is printed, it will give whatever you have stored in it. So that was the use of scene and cout. Now we'll move on to the sixth token, that is operator. So operator are used to perform operations. So C++ divides the operator into following groups: arithmetic operator, assignment operator, comparison operator, logical operator, and bitwise operator. So these are different symbols or keywords that we use with symbols that we use with operator of plus, minus, multiply. This you already know. Then there's something called as modulus. It returns the division remainder. So like if we use, I will go into the future, I will give some problems on it. This increment, if you want to increase the value of the variable by 1, then we use increment operator. Then if you want to decrease the value by 1, then we use decrement operator. Then there's assignment operator, the first arithmetic operator we have done. Now we are moving on to assignment operator. So assignment operator are used to assigning value to a variable. The left side of the operand of the assignment operator is a variable, and the right side of the operand is a assignment operator is a value. So the value on the right side must be of the same data type of the variable on the left side. Otherwise, compiler will give error. So these are the different assignment operator. Equal is an assignment operator. Like if you do C equal to A plus B, so the value of A plus B will now be contained in C. There's also plus equal to. So plus equal to C plus equal to A is equivalent to C equal to C plus A. So this is a shortcut. Instead of using C equal to C plus A, you can just write C plus equal to A. Then the compiler will understand you are telling him to do C equal to C plus A. There's something, there's minus equal to C minus equal to A equal to is equivalent to C equal to C minus A. So I won't go into each and everything, but you can check it out yourself. No need to go over this part. This is another topic also. It is a manipulation of the binary numbers. So just try to read till here and search it on the internet if you find any more information on it. But don't go into here. If you want, you can go. If you want, you can go. Now we'll discuss some problems. All this. So you have learned about arithmetic operator plus. So int sum1 equal to 100 plus 50. So the sum1 will store the value after addition. So 100 plus 50 is 150. So sum1 will now store 150. Similarly, now you can, instead of both being numbers, one can be a variable and one can be a number. So now the variable already holds 150. So 150 plus 250 will be now 400. Similarly, you can do variable plus variable addition. You can divide a variable by a variable. You can use modulo operator on variable and variable. So now we'll move, see some example of increment and decrement operator. So if initialize, int will be small, int a equal to 1, then we have incremented with a plus plus. A plus plus increment it by 1 value. Then we printed. So it was 1 here. So now with a plus plus, it is equal to a plus 1. A equal to a plus 1. So it is actually 1 plus 1 equal to 2. So now a will store 2. That's why if you print it, cout arrow operator equal to a, cout arrow a, so it will give you 2. And if you now decrement it with with decrement operator, then it will now again become minus 2 minus 1 equal to 1. So now I want you to see this code and tell me what do you think will be the value of a, the two print statement that I'm writing here. What will be the value? Write it in the chat box. int a equal to 3, a divide equal to 3. That means a equal to a divided by 2. Now we are printing it cout a. So it will give some value over here, and it will give some value over here. So let me see. 1 and 1.5, 1 and 1.5. So this is 1, this is 1.5. Yeah, this is correct. Now tell me what is wrong in this code. Do you see anything wrong with this code? There's something wrong. If you run this code, then compiler will give error. Yes, capital. The int should not be capital. It should be small. That's why in the previous slide also I intentionally changed the capital this one. There is another error. Can you find it? Yeah, double declaration of it, correct. So you have declared int as a as int over here. You can't again declare it. So we are again declaring it as float. The compiler will give error telling that the declaration of a again cannot be done, something like that. So we have to use another variable over here if you want to do it. So now we'll do it. Now it won't give any error. This is completely error free. Now let's move on to comparison or relation operator. We have discussed about arithmetic assignment. Now third operator, that is comparison and relation. So a relational operator is used to check the relationship between the two operands. Comparison value operators are used to compare two values. The return value of comparison is either true or false, 1 or 0. So these are the different relation operator. Equal to. So 3 equal to 5, that is, it is checking if the two sides of the operator, that is 3 and 5 are both the same. So since 3 and 5 is not the same, it will give us false. So now we are checking 3 not equal to. Is 3 not equal to 5? Are both different? Yes, both are different, so it will give true. So now is 3 greater than 5? It is also comparison. 3 less than 5, it is a comparison. 3 less than equal to, 3 greater than equal to, all these are comparison. I won't go discuss everything. I think it's obvious. So now we'll talk about logical operators. So we use logical operators to check whether an expression is true or false. If an expression is true, it returns 1, whereas if the expression is false, it returns 0. So these are different logical operators. And or 0, 0. So you might have you might know about AND logic gate or logic gate. So it is similar to this. Only this is AND logic, this is OR logic, this is not logic. Logic AND. So if both the expression are true, then this entire statement will give you true. If both the expression are OR, then this entire statement will give you OR, and it is false. If one of them is true, it will give you true. If one of them is false, it will give you false. So in this statement, if the expression is true, then it will return false. If it is false, it will return true. So now we'll go into conditional statements. Now we'll move on. Only few topics are remaining. That is if-else. That is conditional statements and loops. After that, we'll move on to practical session. So conditional statements, C++ has the following conditional statements. Use if to specify a block to be a code to be executed. So I will go into detail again. So just read this yourself. I will directly move on to if else. So conditionals. So if else is the most simple decision making statement. It is used to decide whether a certain statement or block of statement will be executed or not. Like if we write if and condition, this is an expression. So if the condition is true, then it will go inside the if block. If the condition is not true, it won't go. So this is only if part. So there is also else part. So if you use if else like this, then if this condition is true, it will execute this block. If it is not true, it will execute this block. So now let's move on to switch case statement. Let's see if there's any doubt. If any doubt, you can write it in the chat box. Okay. There's only a few more slides and we'll be done. Switch case statement. A switch case statement allows a variable to be tested for equality against a list of values. Each value is called a case, and the variable being switched on is checked for each case. So let me explain. So this is the syntax. So this is the keyword that we use, switch, then an expression inside the braces. So if this expression is matching with any of the cases, this will be a constant expression for this case. This will be a constant expression for this case. So if this expression matches with this case of constant expression, then it will execute this block, and then it will come out of the switch case. If the break statement is used in each of the case block, so that if it enters any of the case, then it will come out of the entire switch case expression, entire switch case block. If you don't give this, then after entering here, it will also check for this, then this. So we don't want that. We want if it enters, if it matches one case, then just come out. Notice that there is also a default case. So if it does not matches any of the case, then this default part will be executed. And default does not have any break statement. And you can also see that there's optional written here as comment. So this is not a part of the code, but I'm telling that if you don't write this break statement over here, the compiler won't give any error. So now there's some rules of switch case statements. I won't go into it. So I will leave upon you to read this. Now, this is an example code of how we can use switch case. So like we have, this is a basic, we already know, like header file using namespace std, int main. So now we have declared, we've initialized the grade with a value d. It is a character data type, and it contains the character d. So now we're using this switch case on this grade variable. So the grade will be now compared against all these cases. So if it is if the grade is equal to character A, then it will execute these statements. If it is equal to B, then there is nothing. C, there's a mistake over here. Anyway, if it is C, then it will execute well. It will print well done. If it's D, then it will print you pass. If it is F, it will print better try again. If none of it matches with none of these values, then it will show invalid grade. You can also try this code if you are interested. After the session, you can try this code. So let's see another. Here we have used character. Now we'll use an integer number as the expression of the switch case. So case 1, case 2, case 3, we're checking if X is equivalent to case 1, if it is equivalent to case 2, if it is equivalent to case 3. Or there's also default. You can write break and not break here. It is optional. Because this is the end of the switch case. So if any of this is not true, then automatically it will come over here and it will reach the end. So break isn't necessary in default. Now I will some important points about switch case statement. The keywords, important keywords. So break, this keyword is used to stop the execution inside a switch block. It helps to terminate switch block and break out of it. And default, this keyword is used to specify the set of statements to execute if there is no case match. If none of the cases are true, then execute the default block. So break is also in use in loop. We have just seen two different conditional statements, that is if else, switch case. In switch case, we use break. In if else also we can use break. Now in loop also we can use a break. So I have given the proper definition over here. C++ is a loop control statement which is used to terminate the loop. As soon as the break statement is encountered from within a loop, the loop iteration stops and flow of control returns from the loop immediately to the first statement after the loop. So syntax break. There's also something called as continue. Continue is also a loop control statement, just like break statement. Continue statement is the opposite of break. Instead of terminating the loop, it forces to execute the next iteration of loop. So now we'll come to loops. This is the last part. There are 3 types of loops. We'll discuss the 3 types of loops. Then we are move on to the practical. Loops in programming come into use when we need to repeat or execute a block of code again and again for a certain number of times, or it can be infinite also. Then the compiler will give error. It is a sequence of instruction that is repeated until a certain condition is reached. So there are many types of loops: entry control loop and exit control loop. Entry control loop, in this type of loop, the test condition is tested before entering the loop. And in exit control loop, as the name suggests, in this type of loop, the test condition is tested or evaluated at the end of the loop. So therefore, the body of the loop will execute at least once, irrespective of whether the condition is true or false. So this is different. We have just discussed entry and exit. So in entry control loop, there are 2 types: for loop and while loop. In exit control loop, there is only do while loop. So this is a syntax. I will go into it over here also. So for loop, first for loop. A for loop is a repetition control structure which allows us to write a loop that is executed a specific number of times. The loop enables us to perform n number of steps together in one line. So this is a syntax. We initialize the expression in the before the first semicolon. Then there's in the second semicolon there is a text expression. Then in the last these are 3 parts. So the first part is initialize expression. This is in the middle part. This is a text expression, and the last part is update expression. So we have just talked about the condition of when the loop will terminate. So this text expression or the middle part that is tested after every iteration. That is, after executing the loops one time, it will check the test expression if it's true or not. Then again, it will if it is true, then it will go inside the body of the loop again and execute the lines of code. Please check down again and again. Update expression is used to update, as the name suggests, and initialize, as the name suggests, we are initializing the expression that we are checking. So now the second type of loop is while loop. While loop are used in situation where we do not know the exact number of iterations of loop beforehand. So in for loop, we already know this many times of loop, this many number of times the loop will execute. But in while loop, the loop will execute until the test expression is true. So once the test expression is false, it will terminate. So this is the syntax: while braces test expression, then curly braces, then there are some statements, then we'll update the expression over here. Here we are updating over here, and here we are updating inside the body. Now we have just learned about while loop. This is do while. This is the exit control loop. This is only exit control loop. So in do while loop, also the loop terminates on the basis of text expression. The only difference is that the test expression here, it was tested before we enter the loop. Here it is tested at the end of the loop. So in do while, the loop body will execute at least once. We have already discussed this, that it will execute at least one irrespective of the test conditions, because it is exit control. So it does not check before entering the loop that if the expression is true or not. That's why it will enter irrespective of the condition. So and one thing to remember is that we have to use semicolon after the end of the loop. Like in this expression, this is the syntax. First we write do, then curly braces, then we'll check the expression, and here it will end with the semicolon. This is important. If you don't write this, compiler will give an error. Similar to while loop, we update the expression inside the body of the loop. So now these are some example codes of how we can use for loop. So first include header file main. So for int I, this the first part is initializing the expression. Then the second part is test condition, the test expression for when to exit the loop, and the last part is the update expression, so how we are updating it. So we know that plus plus is incrementing by 1. So this program will print will print hello world 10 number of times, right? So now, and this is also while loop, same code of we can write printing the hello world 10 number of times. We can do in while loop also. Like we have initialized the expression over here, then this is the test expression, and this is the update expression. Notice here that we are initializing it inside the loop, in for loop. We can also do outside, but here we generally do inside the loop. So, but here we are doing it outside loop. We have to do it outside the loop. There is no other way. So, yeah, this for while loop we can, in this way we can print hello world 10 number of times. And for do while loop also, initialize expression outside, and test expression is over here, update expression is over here, and this will also print the hello world 10 number of times. So if there is any doubt where do while loop is used, is there any specification that at some point, some situation we use while loop and other places do while loop? Yeah, exact situation is not coming at the top of mind, but wherever we need to check and some after it is executed, like if we need something for exit control loop, then we use do while. Or if we need to check the expression beforehand, before we enter the loop, then we use while loop. In most cases, you can use them interchangeably. Yeah, at least once. Any more doubts? If no, then Fahim will take over the session, and you can also open your code editors because you need to code along with him.
Yeah, if you want to code along with me, you're welcome to like open your code editors. Otherwise, you can just follow along.
Yeah.
And you can even write them down in your notebooks or something like that, if you like. So I guess we are ready, Neeraj?
Yeah. So
let's start.
let's stop sharing. Okay.
Yeah. Okay, so let's start the second half of the session now. And let me share the screen. Can you see it? Neeraj, is it visible?
It's
Okay. Then, so now that Neeraj has laid down some basic foundations of how to achieve different things in C or C++, let us dive straight into problems to understand better how these things actually work in real code. So we'll consider some real problems and build up along the way. We'll write the solution ourselves. We break down the problems into steps. We'll go to the solution, we'll go to the editor and code along to get the hang of how things work. Okay, so right into the straight first problem, which is finding the sum of digits of a number. So it's a very basic problem where suppose you have been given a number like 257, and all you need to do is you need to take the digits of it and sum them up and return that sum, or otherwise print that sum, find out the sum. All right. So to do this, essentially what we need to do is, now let me give you a tip here. In my brief course of programming, what I have found, something that I have found really helpful is breaking the problem down into steps. So whenever you're given a problem, it is always helpful to break down the problem into steps, small steps, so that you know what to do when, because the human mind, it can't think of everything at once, right? So it helps breaking the problem down into steps. And that's exactly what I'm going to do here. Okay, so what would the steps here be? The first step would be to extract the digits of the number, right? Why is that so? Because see, 257, if I want to sum up the digits, I need to have them separately, right? So 2 and 5 and 7, they will add up to 14. So that's exactly what I'm going to do. I'll extract the digits in the first step. Nextly, I'll keep summing them in a variable called sum. Basically, I'll have a running sum where I'll be storing the sum of the digits. And this sum will initially be initialized to 0, because there's nothing in the sum when you're not having any digit, right? So you maintain this variable sum and you sum up the digits and keep in it. And let us now see how to do that in code. Okay, so this is basically, yeah, anyone?
Divide by 10. By the way.
Yeah, right. We'll come into that. Okay, so this is basically Microsoft Visual Studio Code Editor. It's a popular editor that we use for writing programs and compiling them after that. You can find it online, and Microsoft's main page has the steps that you need to follow to install the various things and the compilers therein. Okay, so I'm creating a new file here, calling it 1.c. Usually you want to name the program in a more meaningful way, but since it is a problem session class, 1.c seems fine to me. Actually, it should be 1.cpp because we will be coding in CPP today. Okay, so let me write this down as 1.cpp. Okay, so first of all, in the code, like Neeraj has already introduced to us, there are some formalities. What are the formalities? Stuff like this. The first line would be hash include IO stream. I'm including a class basically, which will help me use the input and output functions that C in and C out. By C out, you print something onto the terminal or the screen, and by C in, you just take something from the user. And the next line is using namespace std. Having done these formalities, we need basically what do we need? You can also write comments in our program like this. Within this, we can write comments. Finding the sum of digits of a number. Like 257, the example that we were just considering, 257 would give us 2 plus 5 plus 7, and that would be equal to 14. Sorry, 257. What was the example I was considering? Yeah, it's 257. It should be 16 actually. You say no, it's okay. It's 14 only. I'm messing up things. Okay, so it's 14. All right, so to do this, we'll first of all need a function. Now, a function would basically be, consider it like a black box, where we'll feed something to it, and we'll get something out of it. We'll feed an input and receive an output. Okay, and inside that function, something is going on, which we will come to now, because we are the designers. We need to make it. So let's do that. So this is the black blocks or the function I'm talking about in sum of digits. And this function is going to take in a number, int num. Now let's, now do you remember the steps that I broke it down into? Basically, we need the digits of this number. So I declared a variable called int d. And to keep track of the sum, final sum, I declare a variable called sum. Now what I'll do, I'll go and extract the digits of this number. So while num is greater than 0, I'll come to this, what's happening here. Let me first write down the thing so that I can form the basis to explain something. Okay, so d equal to num mod 10. Let me just write it down quickly. Sum plus equal to d, and then finally num by equal to 10. Okay, now let's come and break down this code. So what's happening here is essentially that whenever num is greater than 0, we'll go inside this loop. We have already discussed while loops in our first part of the session. Whenever num is greater than 0, we go inside this loop and we extract the digits of the number. This d will be storing the last digit of the number. And how is this working? Think of it. Suppose we have 1, 2, 3. Num is 1, 2, 3, let's say. If num is 1, 2, 3, and this particular operator, which you probably already know, Neeraj has covered, I guess, is called the modulo operator. So what it does is it gives you the remainder after you divide something with this, whatever comes after. All right. So when you divide 123 by 10, you will get the quotient as 12, and you'll get the remainder as 3. Now notice that 3 is also the last digit of the number. So essentially this always happens, that whenever I'm using modulo 10, I'll get the last digit of the number. So I'm getting 3 out of this. This 1, 2, 3 mod 10 would give me 3. Okay, so the next step is summing up the digits. So in this variable sum, I'll go on adding the digits. And after that, I will update this num. I'll update this num. How will I update it? I'll make this num as num equal to num by 10. Now this is a syntactic sugar, and what it basically means is that this is same as writing this. Sum plus equal to d is same as writing sum equal to sum plus d. Now in the third step, we are doing the same thing, num equal to num by 10 or num by equal to 10. Now what this does is it takes 123, suppose, which was my original number. Let us take for an example sake. What it does is it divides the number by 10, and since it is an integer, it will store 12. The num will now become 12. Like Neeraj had already shown an example there. 1 divided by 2, something like that. No, 3 divided by 2 it was, I think. Yeah. So when you divide 3 by 2 and the variable involved is an integer, then you'll get 1 and not 1.5 because it's an integer. Okay, so that's how it works. And that's it. At this stage, we'll have the sum stored in our variable sum. And all we need to do here is return sum. Let us write the driver code for this so that I can show you how this program works. Now again, I'm maintaining some formalities. The driver code is usually written within the main function. And this is the basic construction of the main function. These are the things that are constants in a program. You always need to write this to make sure this code is syntactically correct. These have their own functions actually, which you can learn in depth. But for purposes of this course, we'll just stick to the representation. Okay, so the first thing would be I'll print a message in the prompt saying that enter a number. What this does is, it asks my user to enter a number so that I can find the sum of its digits, right? Let us declare that number, int n. Now, there's a convention where you declare everything at the beginning of the program, and we can also use that. You can also stick to that. That's a good programming habit. It's an aspect of readability of your code. Okay, so cin n. This will take my n as input and store the number whichever user is entering. Okay, so I'll have another variable called sum to get the sum in the driver function, and I'll store this in I'll store the sum of digits of n in this variable. And once I do that, I should have gotten the sum at this stage. All right, now sum, yes. So I guess we are done here, and let's just run this program to see if it's working. Okay, so my program is asking me for a number. I'll enter a number, 1, 2, 3, let's say, and I should get, okay, something went wrong here. It's returning 9. So what could be the error here? Let us see. This is another aspect in programming where you check your program for errors. Like your program might not, even though it is a very simple program, and I'm actually, I don't know why it went wrong. But many times in more complex programs, you would like to debug your code after you have written your code. Most of the things should be correct in your code if you've written it logically. But there are times when things go wrong, and I can already see where it went wrong. For illustration purposes, I wrote this as 1, 2, 3, but I forgot to change it. Okay, let us see now if it works. And voila, 1, 2, 3. This should give 6, which it is giving. Now see that it looks a bit ugly here because this percentage, I never mentioned a percentage in my program, right? Now this is happening essentially because I didn't print an extra line after printing sum of digits, which I should. And there are two ways to doing this. One is like this. This is an escape character for the new line, \n. And whenever you write it, it just prints a new line there. There's alternative way of doing this, which is just writing NL. And this will also print a new line. And now my output will look better, will have a better look. 1, 2, 3, sum of digits equal to 6. So congratulations, you have your first program. Yeah, so we have written our first program. And in fact, checking it against just one input would be kind of goofy. So let us also check it against a number of other inputs, 2, 5, 6, 7. What should it return? 2, 7 plus, it should return 20. Is it returning? Yes, it is returning. So our program seems fine at this stage. Okay, so having done that, now there is something, there's a follow-up to this, follow-up problem to this. And what is that? What if I wanted to sum up the digits of the number as long as I get a single digit at the sum. That means that look here, 3, 4, 5. I have 3, 4, 5. I'm summing the digits up. I'm getting 12, but I'm not happy with 12. I want a single digit sum. So I want to keep summing the digits up as long as I get a single digit number. In this case, 3, 4, 5 first gives me 12, but I'm not happy with 12 because it's not a one digit sum. So I just go and sum up the digits again, and I get 3. Now this is a single digit sum, so I like it. Okay. So similarly, if we had 5, 6, 7, 9, the sum of its digits will be 27, and it's not a one digit sum, so I would want to sum up the digits again until it is a single digit sum, and I'll get 9. So just think about how we could have done this problem. Okay, so how we'll do this is we'll add another function to the program. We'll still use this function of summing up the digits, whose purpose in life effectively will be to sum up the digits of whichever number I feed into it. But on top of that, so that I can get a one digit sum now, which are my present requirements, I need another function which will just give you the one digit sum of anything you feed into it. And let me just show you how to do it. Int n, it takes a number called n. Okay, something went wrong here. Okay, that's because of that. Yeah. So int one digit sum, I take in a number. And what I do essentially is initialize another variable called sum, and this will store the sum that I want to finally return, that one digit sum. Okay, so initially I'll put n in here, and I'll just run a while loop here. Okay, I'll explain this after I have completed writing. While sum is greater than 9, okay, so what I did here was I initialized sum, which I'm going to return at the end, with n, the number that I'm taking in. Suppose 1, 2, 3, 4 is that number. And what should be the sum of digits of it? 1, 2, 3, 4 should give me, first of all, 10, I think. 1, 2, 3, 4, yes, 10. And after that, it should give me finally 1. Okay, let me see if that is happening. So I'll initialize my sum with n, the number itself, 1, 2, 3, 4, which I'm accepting as parameter. And as long as this sum is greater than 9, that is, the sum is 2 digit or higher, then I'll go ahead and store in sum now the sum of digits of sum itself. I think I confused you. So basically, if I had 1, 2, 3, 4, I'd just go into this loop first, and I'll store the sum of digits in it. So sum of digits of 1, 2, 3, 4 would be 10, but 10 is still greater than 9, so it will go into that loop again, and I'll get the sum of digits of 10, and I'll get the sum of digits of 10, and that will be stored as my new sum. And that is effectively returned at the end. And if I want to test my code, then I can go here. Now notice that I also used I just used an existing function in the program. So there are different functions that can help you achieve different tasks, and it is often wise to break down your program into different functions so that you have a better understanding of how your code is going to work. One digit sum. And this should be changed. to one digit sum now. And it should run. I'm entering a number 1, 2, 3, 4 should give 1. And you see we get the output as one digit sum equal to 1. All right, so we're getting the required output. Let me compare it against one more input case, 5, 6, 7, 8, let's say. Sum should be 8. So if we see 5 plus 6 would be 11, 11 plus 7, 18, 18 and 8 would be 26, and 2 plus 6 is 8. So we are getting the correct answer. So that is how you solve the follow-up problem here. All right, let's move to the next problem. The next problem is another simple one. Finding the maximum among three numbers. Now, we are given three numbers, for example, minus 30, 55, and 32. And we want to return the maximum out of those numbers. Suppose these are test scores of a student. Okay, so possibly someone won't get minus 30, but we can't say these days. Okay, so basically we want to return the maximum number out of these. And you can see the maximum number in this case is 55, so that is returned here. Again, breaking down the problem into steps, that is one important thing. Let us do that. So step one would be compare any two numbers. Suppose compare 30 and 55. Now, whichever the greater number among those is, would be compared with the third number, and that is my step 2. And the greater number found in step 2 would be my greatest number. So I'm comparing two numbers at a time. I'm checking two numbers. The greater, I'll store the greater in some. I'll check which is greater among two numbers, and whichever is greater, I'll check it with the third number, and the greater among that two will give me what the greatest number out of the three is. So let us see this in code now. All right. Now notice that I'm using a particular convention for naming my variables. This is called camel case, where you want to capitalize every word that you want to indicate in your variable, just to make your variable look meaningful. It enhances the readability of your code. The user or the developer, if any other developer is checking your code, then he can understand what you mean. Okay, so again, the basic things, let me write down at the start of our program. Yeah, so what we need here is maximum out of three numbers. So we need a function int max, max of 3, let's say. We need three numbers to be fed here, among which we have to check which is the greatest one. Now, does somebody recall what the first step was? Anyone from the audience? Can he say? Anyone just say what the first step was, if you recall, so that I understand you're listening. No one? Okay, maybe I'm teaching in a boring manner. Never mind. The first step was to compare two numbers. And let us compare A and B. Now, if I go into this condition, if I go inside this if, this means that A is actually greater than B. Now, if I know that A is greater than B, why don't I check that if A is greater than C as well? And if that is the case, if A is greater than C, then I can safely return C. I can safely say that C is the greatest number here, sir, and you have it. Otherwise, I'll go to the else part. And if I come to this part, this essentially means that A is not greater than C, or C is C is greater than equal to A. Now, for our purposes, so as to avoid ambiguity, we'll just give unique numbers in here, A, B, C. Okay. So if A is not greater than C, then that means that C is greater than A. We basically do away with we basically keep the equality part outside of our discussion. Else, I can say that A is the greatest number, and I return A. Otherwise, if A greater than B, okay, so here A was greater than B. If I was within this conditional, then that means that A was greater than B.
Excuse me if
If that was not the case, yeah,
I
say.
check the chat box from time to time. People like to interact with you through the chat box instead of
Yeah.
okay.
Okay.
Someone said something important. Check it now.
Okay, let me see. I think it will be return A. What will return A? In the function created, it will return A. Yeah. So maybe he was prompting at some particular time. When A greater than, yeah, absolutely. That's what we did. That's what we did, in fact. Yeah, A will be max, absolutely. And any questions, Neeraj, which I need to address?
I think you returned wrong variable. Check it once again. Show me once again.
Which one?
Show your code.
Yeah, here. Oh, okay. I returned C. Sorry. Right, absolutely. I should have returned A. Returned A here. Yeah. So I was saying A, but I was writing something different. Otherwise, if C is greater than A, then it should return C, and C will be the maximum number. I would have corrected it eventually, though. Don't worry. Anyways, I'll check the chat box. Yes, that's a good point. Else. And when do I come to else? I come to else when A is not greater than B. And since the numbers are unique, then that would mean that B is greater than A. And if B is greater than A, I'll just go ahead and check if B is greater than C as well. If that is the case, then I'll return, again, not C, but B. Else it would mean that C is greater than B. That is, B is greater than A, but C is greater than B itself. And that effectively means what that means is that C is the greatest number. And at this point, we would have gotten the maximum of the three numbers. All right, I think we are ready to proceed to the next. We'll just write the driver function for it quickly so that we can see our code running and feel good about it. Return 0. Again, those formalities that we do. And even there's a greater formality here. Some people write here void, and even I like to write that. So you could write that. That basically means that nothing goes here. All right. In the main function, I'll just take in three numbers. And in fact, I'll just hard code three numbers here. Int A equal to 3, B equal to 7, C equal to -9, let's say. Yeah, C equal to -9. And I want to find the maximum of these three numbers, for which I have a function. Maximum is max of 3. Whatever the maximum of three numbers would be will be returned here and printed duly. So I can pass in here A, B, and C. And it should print the maximum number. Let me see if we're getting it. Okay, we got it. The maximum number was 7 in this case. Suppose I made it -7, then we should have got 3 as the answer. Are we getting it? Yes, we are getting it. And again, that thing, so as to make our output look a bit presentable, we'll just add a new line here. And you'll see that that prompt goes to the next line. Okay, so that was about it. Comparing 3 numbers and checking what's the maximum among them. Now, I could have done it in one line. And how I would have done it is by using the conditional or the ternary operator. So how that works is something like this. Yeah, so this could be a one-liner code, all this mess I didn't need. And I could have written it like int max equal to a greater than b. A greater than b, this is a conditional. Okay, let me just introduce you to the syntax of this quickly so that you know how to use it. So basically, you take a variable and you give it the variable, give it the value, you give it a condition to check, and then this question mark as it is. Then you execute expression. If it is true, then you execute expression 1 if the condition is true. Otherwise, you'll just go to expression 2. So this is how it works. And in fact, you can nest it like this. Variable, condition, condition 1. I'll go ahead and check condition 1. And I can have another condition here. If this condition is true, this first condition, then I'll go to the second condition and check if it is true. And if both are true, then this will be evaluated. This will be set as my value to my new variable. Otherwise, I'll check a different condition if this is the case, condition 3. And if that is the case, I'll just, okay, so there should be another expression here. Expression, let us call this 1. Then we can call this 2. Expression 2. I'll break it down, don't worry. It might look scary in the first glance. All right, it's looking scary even to me, to be honest. Yeah. Then we go ahead and check condition 3. Expression 3. Expression, I'm just writing it down, I'll explain later. Expression 4. So there are 4 possible values that this variable can take, and that will completely depend on what are the set of conditions that are true. If my first condition is true, condition 1 is true, then I'll go ahead and check if condition 2 is true. If condition 2 is true, then expression 1 would be the value of the variable. If that is not true, then if condition 2 is not true, then expression 2 will be the value of my variable instead. And in fact, if condition 1 is false to begin with, then I'll go and check condition 3. If condition 3 happens to be true, then expression 3 will be my variable's new value. Otherwise, if condition 1 is false, is still in that, and condition 3 is also false, then we'll have the expression 4 as the value of my new variable. So that is how it works, and that is how I have used it here. So see, basically this is the ternary operator. This combination is called ternary operator. This question mark followed by a colon. You have some condition here. You have some condition here. And then you have some expression here. Yeah, some expression here, another expression here. And depending on the condition, the first one would be executed if the condition is true. Otherwise, the second one would be executed. That's how it works. So this should basically give me the answer in one go. And it is nothing but you're using nested loop in a bit more nested loop, not nested loop, sorry, nested if statements, but in a bit more succinct way. And let me just illustrate that quickly here. If you're not running short on time, okay, I'll be quick henceforth. Okay, so this should give me the value again. Okay, there's some warning here. Okay, let me see. Maybe I didn't save the code. Okay, no. Yeah, let me see what the problem is here. I shouldn't, if A greater than B. Did I miss something? Okay, I needed to return a value here actually. Return max. At the end of my calculation, I always want to make sure that my function is returning a value as long as it has a return value, as long as it is not void. It should be returning some value, and that will be of the type that is mentioned here. Okay, so I forgot that, and the compiler yelled at me. So that is, those are some points that you would like to keep in mind. So see, you're getting the output 3, and which is the case, 3 is the maximum number of the tree. So we did get it in one single line. And we're done with our second program. Now there is a follow-up to this. Now this was pretty boring, doing it with 3 numbers, like not very helpful, not very interesting. How about we had more than 3 numbers? If we had more than 3 numbers, then we can go about it like this. Now, there's an effective way to deal with more than one numbers in C or C++, that is using arrays. Now, let me just give a quick introduction to arrays. Arrays are basically a data structure which lets you store numbers, more than one numbers of the same type, essentially. In C, you can store only variables of the same type, multiple number of them, in a single variable, and you can access them via a single variable name. That's how arrays are useful. So we have a problem here to illustrate this. Find the maximum among 10 numbers. So suppose you are given 1, 2, sorry, 1, 2, 3, 4, 5, all the way up to 10. Then I should be returning 10 here. Now how to do it? Let's break it down into steps. Now what the steps will be are like this. Store the numbers in a data structure, which is essentially array in our case. Now a data structure is something that is basically a container where you store multiple data, and it facilitates certain access or manipulation of data. Okay, so that is the first step. The second step would be to select a random number out of these to serve as a basis for comparison. So I'll just pick out one of these numbers and call them the maximum value. I'll just assume that it is the maximum value right now. There's no harm changing it afterwards. So I can just say that it is my maximum value at this stage. So get yourself a variable to store the maximum number. Assume that this random number is your max for now. Compare each of the remaining numbers with this number. So this variable which I have assumed to be the maximum number as of now, I can compare this with the remaining numbers, and that will tell me if it is actually the greatest. Otherwise, I'll just store the greater number here. I'll just keep storing the new greater number I get in that maximum variable, and at the end of searching all the values, I will have gotten that desired answer. So let us just write the code for it. Okay, so to make things a bit fast, I will not repeat things. Okay, I will have to repeat it anyway. hash include IO string. Okay, I can just copy that. I'll copy the main function. I'll steal it from here. Okay, stolen. Then I need to write the function. Okay, I'll edit the main function later. For now, just ignore it. So to do this, I'll need what? I'll need a function that returns the max, int max number. Let me just call it give max. That's a better name. Give max, and I'll take the array within. I'll take the array in it. I'll take the number of elements that this array has. I have to provide this because I have to provide it. Otherwise, I won't know. There are ways to know actually, but that would be a bit advanced for the introductory class. So I'll just take the size for now as a separate parameter. So yeah, so what was my first step? My first step was to assume, take a random number and assume it to be the maximum one. So let me just take the first number. Why should I break my head about that? I'll just take the first number, AR0, and that's how you access numbers in an array. You use the array name, and yeah, also notice that how we take in arrays like this, int AR, and then followed by square brackets, opening and closing square brackets. Okay, so I take a number out of this, the first number in the given array, which is a list of the numbers that I am to check for the maximum one. And I take the first element of it and I store it in max, considering that this is the max at this stage. Okay, I don't need that comment here. Okay, so next thing I want to do is go over the remaining numbers. I less than n, which is the array size. So to go over the numbers, I need a for loop basically. This for loop is doing nothing but generating the indices of the numbers that I want to go over, starting from I equal to 0 to up until n minus 1, I equal to n minus 1. So that is the last index, and that is how indexing works in arrays. You have indexing starting from 0. Like if you had elements like 3, 4, 5, 6 for the array, then these are the indices, respective indices for the array. 0, 1, 2, 0, 1, 2, and 3. And if you want to access 5, for example, you would use the array name and then followed by square braces, and within that will be 2. Okay, so this for loop is basically generating the indices so that I can traverse over the elements, I can access those elements. And what I want to do here is I want to keep checking if max is greater than ARI, then I'll just update max to this new one. If ARI happens to be greater than max, then my max is not the maximum at all. My ARI should be the maximum at any stage, because if ARI, so I wrote it the other way. This should be, let me go again. If ARI greater than max, but that's absolutely contradictory, because if ARI is greater than max, then why call it max in the first place? Let's just call this max ARI, and that's why I said ARI in max. All right. So if ARI is greater than max, then max equal to ARI. And at the end of this loop, I will have got my maximum number. Neeraj, if there are any questions that then you can just like tell them to me, okay? Because it's quite hectic having to check the chat box again and again. You can just tell that to me.
Okay.
Yeah, thanks. All right. So at this stage, we'll have the maximum number. We should have. Now, let us hard code few numbers here. Now, hard coding is nothing but giving your values, giving values to your variable in the program, rather than taking them from the user. 3, 4, minus 6. Now, there is a catch about this code which I'll discuss. I don't know if anyone has observed it yet, but right now focus on this. Okay, so these are my numbers. Let me make it minus 10. So I should have 9 as the maximum out of this. Yeah. So this is my array. And I want to pick the maximum number. Maximum is not max of 3 now, but max of any number of elements I like. Give max this array, which is called A. And how many elements does it have? 1, 2, 3, 4, 5, 6, 7. 7 elements. All right. So this should basically give me the maximum number, that the number which is maximum in this array. So let me just check my code once. I don't like it to crash again and again. Yeah, maximum is give max. All right, give max. Let's take something number. Assume that 0. That doesn't want to. Where I is greater than max. Whenever this happens, I want to do this. I reach the end of the loop. I just return the max. Okay. So that quick check was done. And now if I execute this, I should be getting 9. And that is what I'm getting. Maximum is 9. So as simple as that. But I'm doing something extra here, which can anyone point out what task I am doing extra here? Just open your mic, no problem. You can speak.
Brother, I have a doubt that in the given function, we have taken two things like integer array and integer number
Yeah.
in the give max.
Yes.
Why do we add it int n?
Actually, you're not clearly audible. Is it only me, or is he not clearly audible?
Yeah, there's some background noise.
Yeah. Did you hear his question though?
No, I did not understand.
Okay, just write it in the chat box, whoever it is. Who is it? Let me see.
Brother, am I audible now?
Yeah, can you please just write in the chat box? I couldn't hear you. There's some background noise, so it's creating some problem. Write it in the chat box and let me see. That will also give me a break.
Also, Fahim, this is the last problem, right?
No, we have one more.
We should end it by 9 p.m. Otherwise, it would be more than 2 hours.
Okay. I'll be quick. Okay.
Okay.
Okay. In the function this, why we included n? Is it important? Yes, it is important because as you can see, in this step, I am using it. So I need n here, the number, the size. There's an alternative, like I said, there's an alternative way of doing this, which I won't cover now because it will be too much information to consume in a day. But if you can self-study, basically the goal of this course is to get you started so that you get that motivation to learn these things. Because everything can't be covered in these sessions. We'll consider the maximum things, but you do have to do some self-study because it's a vast thing, right? So yeah, for now we need this n because I'm using it here. I need to know the size at this stage. Okay. So that was it. That gave me the correct answer, and we can move on to the next problem. Okay. So
Also, Fahim,
another, yeah.
you asked the question in the previous problem, right? Something extra that you were doing.
Yeah. I just forgot it. Thank you.
Somebody answered it. Can you check his answer?
Okay. Somebody answered. I don't see an answer. In the function created in the bracket we took, Uh, okay, not that. I don't think anybody answered though. Okay, I'll just answer it myself. So the thing is, it's a little extra task I'm doing because see, I have stored in max the first element already. So what's the point comparing it with itself? When I'm starting with I equals 0, then I'm also comparing ARI with AR0. That is AR0 with max, but max is already AR0. I took the first number and assumed it to be the maximum, right? So there's no point in checking it with itself because it's not going to be greater than itself anyway. So I could have just started from 1 and this will still give me the result. As you can see, I'll run it and I'm getting maximum equal to 9. Achha, is this too small for you to see? Should I? Yeah. So you can see the answer is the same. All right, we'll quickly move ahead to the next problem because we are short in time. Yeah, so the next topic is strings. What are strings? It's not a topic, it will be covered in details later. But I just want to introduce you to programs like this. Yeah, so strings. What are strings? Strings are basically a sequence of alphanumeric characters and or symbols. That is stuff like this. Uh, that is your name. Your name could be a string. If I were to include 1, 2, 3 here, that would be a string too. If I were to include characters here, that would be a string too. Okay. So there are different ways to get string in C and C++. Now C++ allows some, C++ gives you a string class which makes it even easier to deal with strings. But for the introductory course, we'll start with this. We'll consider string as an array of characters. And you can declare it like this, char str square braces. This is an array of characters and and whatever characters I want to put in the string, I put it, and those characters will make up my string, Fahim in this case. And another thing, when I'm declaring it as an array, it's important to end it. It's important to mention its end, but otherwise my compiler won't know where the string is ending. So writing this is similar to this. So chars, if I had written it like this instead, char str square braces Fahim, then it's already doing this. It's already including this null character in the end. So this null character is basically used to indicate the ending of a string. All right. So in fact, you could also have written it like this, char star str. So you can consider char star to be an alias of string, like some just consider this char star as a string type. Char star str equal to Fahim. Yeah. So we have a problem here where we have to remove duplicate characters from the string. And suppose this is my string, FAH with too many H's, too many M, too many I's. And I want to get a single one of each of those characters. Now, how do I do it? I haven't written the steps. I have gone straight into the code. So since we are short in time, let me just elaborate this, whatever I've written already. Yeah. So yeah, that basic formality to begin with, and then the function. Okay, so in the function, I have this char star return type, which like I told you is another name for string. It's used at least as a string. Char star would mean a string. Okay, so remove duplicate. There's more to it actually, which you can self-study, and it's actually elaborate. And for the purposes of code, it gets you thinking of char star as a string puts you in a good position to write codes. But there's actually more to it if you would want to know. Okay, so remove duplicates is the function wherein I take a character array, and remember that this is another way of taking a string. And I also put the number of characters in that string here, just like I did in the previous case, which was also an array, the previous problem. Okay, so we initialize a variable called index, we set it to 0, and this index will be basically the index of the modified string. Whichever character I add, suppose this modified string has FAHIM, right? So when I'm adding F, the index will be 0. When I'm adding I, the index will be made 1, and like that. So my first step will be to traverse to all the characters of the given string. For that, I again use a for loop. I use a for loop to basically go over the indices of this original string, and then I'll go ahead and start another loop which will go up to the previous index of the index that I'm currently considering, and it will check if that character was already there. So this part is crucial to understand. Like, I'm going through every one of the characters one by one, F, A, H, H, I, I, M, M. So F, A, H, the moment I go to H, the moment I go to this second H, I will be checking if that H is present in the earlier part or not. And that's how to do it in code. You basically take j equal to 0, go up to that index, go up to that index. In this case, it would be 3, I suppose. Yes, so this index is going to be 3, 0, 1, 2, 3, right? And I'll check all the indices up to 2, and I'll look if H is there. And how I do it like this. For j equal to 0, j less than I, j plus plus, if str I equal to str that is if these are the characters. I'm accessing the characters here basically. Just like you would access numbers in an array. Similarly, you can access characters in a string, which is an array of characters, to access those characters. If at any point this happens, that the character was already there, then I'll just break out of this loop. Which loop? This loop, the current loop. And since this loop has ended prematurely, this step will not be executed. Whatever I have written here, this will not be executed, and it will go to the next iteration. When I was at H, nothing actually happened. And if I were to start looking at it from the beginning, from F, from 0, from I equal to 0, if I were to check it from there, then I will see that for I equal to 0, I get inside this loop. This doesn't get executed because this is not true. J is not less than I. 0 is not less than 0, right? So, but j equal to I, that holds. 0 equal to 0. So str index plus plus would store stri. That is str index was initially 0. So str 0 would store str 0. That is from the original string. From the original string is the first character is just stored again in the same position. All right. And the index is incremented. It is now 1. So I'm ready to fill in the next place of my new string. And we're using the same variable for that. We'll basically be editing over the same string. Okay. So the next step would be, okay, so nextly I would come to A. And when I come to A, then I will be 1. And this loop will be executed once. For j equal to 0, j less than 1. So it's executed once. I check if it was there if A was there in the string. So in the earlier part of the string, which was not. So what happens here is I break out of this loop. And since I broke out prematurely, j is 0 here, while I is 1. So this step doesn't occur. So I'm not adding anything to the string. I'm just skipping over this character. Sorry, I just messed up. Okay, yeah. Okay, see, if for j equal to 0, j less than 9, yeah. So if I find that character before, if a particular character had any occurrence in the earlier part of the string, then I break out of it. And if I break out of it, then I will not come to this loop. That means nothing will happen to that character. That character will stay just like it was. Like A was already there, so A is going to store. A is going to still store A. That position is going to still store A, because recall that we are using the same variable here, stri. And like this, it will happen same for H. But when I am coming to the second H, what will be happening is I will go over all these characters and check if this character was there, which was indeed there. Let me see what happens when it is there. So if it was there, which is equivalent to this statement, then I'll break out of this loop prematurely, and this part will now not hold. Yeah, so this part will now not hold. So I'll not be adding that to the string. I'm messing up something. Yeah, so okay, Neeraj, do we have time? Like, can we take some extra time, 10 minutes? If I were to write this code, I could explain better. Because I messed up in the having to keep track of this.
You can give them this problem to do it themselves, I guess.
So it's an obligation that we have to end this class right now. Is it?
It was written in
Okay.
the
Yeah, okay. It's better than, I guess. I can even add an explanation, written explanation to this. In fact, I will be giving you this handouts, this particular handout, that this note. And okay, I'll write the explanation elaborately in the for the last problem. Because we are short in time, so I can't. I'm not being able to function at the top of my potential right now. So I'll just add the written solution to this. Okay. So that's about it. And that was the first class of our DSA session, DSA series. And I hope you get to learn something from this, and it really gets you hooked on to coding, which is a really emerging field. Like it's, and that's the point really of this session, that it no longer depends on which branch you're from, but you're really, everyone is welcome to this field. Coding is something as becoming something as fundamental as maths itself. So yeah, so it's definitely worth learning. I hope you enjoy this session, this entire series. Okay, so let's stop it.